Um, hmm.
Okay.
What should we do?
I guess we better give it a couple minutes and see if she comes back.
How's your family doing?
Great. We're good. I'll have to run into her and my husband and my older kids are all at the temple tonight, so I need to make my little one go to bed in a few minutes. But
Oh, okay.
exciting stuff.
Yeah. I can only imagine being a mom and trying to do school at the same time.
Yeah.
That would be so crazy. Really hard.
It gets a little crazy sometimes. All right. So I was just going to pull this.
Is she off? She's gone now.
Oh.
Hold on, I'm going to try and see if I can add her back into the call. Invitation posted. Okay.
Are you guys both?
What?
What year are you guys both at? You're taking like a combination of online and on-campus classes, right?
Yeah. Yeah. I'm a senior.
Oh, okay.
I'm a sophomore.
Okay. Fun.
Yeah. I kind of put this class off till the very end.
Are you? What's your major? Are you marriage and family studies major?
I'm rec management.
Oh, okay.
I'm psychology.
You're psychology?
Yeah.
Okay. Fun.
Are you marriage and family studies?
Yeah.
What do you want to do with that when you're done?
I want to get my master's and do counseling. So.
That's cool.
I'm like just focusing on finishing this first. I'm a little more than halfway done, so I guess I'm technically sort of starting my junior year. So.
Nice. Wow.
Yeah. It's gonna take me a little longer than you guys though, since I can only take like 3 classes at a time.
Yeah. That takes so long.
Yeah, it takes her. I did my grad plan and I was like, oh, awesome. I'm going to graduate in winter of 2018.
Yes, it's going to happen.
I know. Oh, man.
Oh, this is her calling. Hold on. Hello? Did it? Do you want to do it? I can put you on speaker and we can try and talk through them together, and you'll be on the first part of the call, which is good enough for us to post it. And then we can... Okay. Yeah, that is really weird. No worries. No worries. Okay, I'm going to put you on speaker just a second. Anya's internet isn't working, so she's going to be on speaker for the rest of the call.
Okay.
I'm just going to grab something. You guys can go on. Okay. Can you hear Anya at all?
It's okay. I mean, I can't hear her, but...
Okay.
Oh, now I can hear.
Oh, that's all right. Don't worry about it. Okay.
So did you guys both do the questions already, or do you still want to do them together?
Let's both do them together.
Okay.
Let's see.
On which ones are we working through? Part 2?
Part 2. So 5 and 6, or those only 2? Just 5 and, oh, yep, 5 and 6?
Yeah. Quick.
I just did the quiz. Okay, so for number 2, we had the 4-sided die. It has 4 possible rolls, 1, 2, 3, or 4. And so you calculate the mean of this discrete random variable. And so what I did to find the discrete random variable is I took the value, which when you write it mathematically, it just looks like an x in parentheses, and I did 1, 2, 3, 4. I just wrote it all out. So like I started off with 3 columns. So I wrote value, the probability, and then the value times the probability for each.
Value times the probability. Okay.
So in the value column, I wrote 1, 2, 3, 4, like in a, how'd you say this, stack? In a stack, so it was like 1, if it was line paper, 1 line would have 1, the next line down would have 2, next line down 3, like it, so the column, and it just went down the column, so 1, 2, 3, and 4. And then, what? Yeah. I actually can't hear what you said, but I think you're right. No worries. And then for the, what's the second column? Represent, I'm trying to remember. P times X, that's the probability. For each of those, I just wrote 0.25 or 1/4 because that's the probability of rolling it is 1/4 for each time because it's a 4-sided die. And then for the third column, I put the value times the probability. So I did 1 times 0.25, which is 0.25, and then the next one down I did 1 times, or I did 2 times 0.25.
0.25, yeah.
Yeah, and then I got 0.50, and then I did 3 times 0.25, and I got 0.75. And then I did 4 times 0.25, and I got 1.0. And so then you add all of those together, and that's 250, and that number, that 250, is the mean of the discrete random variable.
Sounds about right, yeah. Okay. Yeah, because I was looking at it earlier, so.
Okay, so does that make sense? Do you guys get that?
Yeah. So you can take the quiz together and do that.
You want to take the quiz? Let's answer number 6 to make sure we all got the same thing. Did you guys all get the square root of 1.25?
Yeah, it's like 1.18.
Yeah. I was too lazy to square root it, so I just wrote square root.
1.118. Yeah, it's like 1.118.
Okay, perfect. So do you want to go ahead and take the quiz together?
Yeah, I haven't been able to pull it up. I did too low, so I'm not sure how long I'm be able to last. So let's take the quiz.
Okay, let's take the quiz.
So internet is both options.
Okay, so number 1, true or false, did you do the preparation? Number 2, true or false, we all actively participated. Okay. Number 3, excuse me. Give all your probable answers as decimals and not as percentages. Human blood can be classified into one of 4 basic types, O, A, and AB. The proportion of people, in the population of the United States with each of these blood types is summarized in the following table. Use this data to answer the following questions. Number 3. Blood types and the proportions given in the table above define a probability distribution.
I would say yes, because they all add up to 1. So you know that was a thing. The proportion is to 1, and I don't know. I think it's true. I don't know what you guys said.
What is the probability distribution? Here, let's look on the. Let me just look on the definition of a
Yeah, we can
probability.
double check on that.
It doesn't even say. That's what drives me crazy about these quizzes is they throw these random, like there's no, it doesn't say those words, probability distribution,
Yeah.
in the text.
I do think it's talking about just probability, and like it's referencing that rule of probability that you can tell that this is a probability problem because they all add up to 1.
Okay.
And it talks about that, but you're right, it didn't say it in a very clear way.
Okay, so true.
Hmm.
What is the probability that a randomly selected person?
Yeah, Anya, we're saying that's true because it would make sense for it to be true.
Okay.
Okay, number 4. What is the probability that a randomly selected person in the United States has type O blood?
Isn't that 0.45?
Yeah, that's what I think it is. And
Alright,
then
0.45.
just 0.45, just like it says in the table. It says
Yeah.
yeah,
Makes sense.
it makes sense. And then number 5, what is the probability that a randomly selected person will not have type O blood?
That'd be
Wouldn't that just be
0.55, right?
0.55? Yeah.
Yeah, 0.55.
Okay. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a patient identified as a bladder cancer patient. Answer the following questions. Okay. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder patient?
Would it be 1 in 6?
So it's 1 out of 6,
And so you divide
but it
that
needs to be a decimal.
0.166666, so 0.17. How many 3 decimal places? So 0.167.
Yeah, 0.17.
It says round to 3 decimal places.
Oh, 0.167.
Yeah.
Oh, yeah. I think it's 3 decimals. Okay. Yeah, 0.167. Okay.
In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer. There is little evidence that dogs can detect bladder cancer.
So it provides strong evidence, right? Because it's very unlikely that they would do it by random chance alone.
Yeah, I think that it's likely as well.
So there's 1 that works on this provides strong evidence.
Yeah, I think it's that it provides evidence because that they basically answer the question in the question. So.
Yeah. Okay.
Okay. And M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of colors in a bag of plain M&Ms is given in the following table. If you reach into a bag of M&Ms, what is the probable drawing of a red colored candy?
Round into 2 decimal places. Okay.
Wouldn't it be 0.13?
I think so, but now I'm starting to wonder, are we like missing something? Because that's just too easy.
No, I actually did my homework in the math lab today, and I asked that question because I was like, that's way too simple. And he was like, no, that's really the answer.
Okay.
So I'm pretty sure it's right.
Okay, so for green, we just have to subtract all the other ones because it's blanked out, right? So we just
Yep.
have to do 1 minus 2, minus
So it's really that simple, 0.13?
You subtract 1 from the total
So is it
of all of the
0.16?
colors.
Did you get 0.16?
1.13? Oh, 0.16.
Did you get 0.16?
Yes, 0.16.
Is that what you got?
So,
Yeah, that's what we got. Is that what you got, Anya?
0.16?
Yeah.
Hold on.
Okay.
Yeah.
Okay. Good. What is the probability that a randomly selected candy is not green? Round to 2 decimals. So
That'd just be 0.84, right?
Yeah. So you subtract 0.16 from 1, and you get 0.84.
0.84?
Yeah.
Okay, so hold on. Slower. That's right. Okay, yeah.
The ACT scores of students admitted to a medium-sized public university in the western United States were taken from Capex.com. The following summary statistics were calculated. Use the information to answer the following questions. Half of the observation are less than equal to what number? Half of the observations are less than equal to what number?
24, right? Because that's the median, right?
Oh, yeah.
Is that right?
So it would be 24. I think that's correct, because the median is
Right in the middle, right?
middle. Yeah. And the mean is so are we looking for the median or the mean? Because the mean is the average, right?
The mean is like add all the numbers
So it
and
would be
divide
the
by the
median.
number. So it would be the median would be the exact center of the list.
Yeah. Okay. Cool. Based on the information on the above table, the top 25% of students scored above what number?
22.
22, right? Because the quartile 1 is 22.
Yeah, it's the first, yeah.
Wait, no.
No,
No,
wouldn't it be? It's because it's the top
Q3.
25. Yeah,
So
it would be
75th
27.
percentile, right?
Yeah,
be
because
27.
Q1 is the lowest.
Yeah.
So it would be 27.
Mm-hmm.
Which of the following statements is not one of the 3 rules of probability? The probability that an outcome will not occur is 1 minus the probability that it will occur. The probability that a number is between 0 and a probability is a number between 0 and 1. If the probability is high, then the probability is positive. If the probability is low, then the probability is negative. The sum of the probabilities the sum of the probabilities in any probability is 1. So I
There's
think
no
it's the
such thing as a negative probability.
There's what?
There's no such thing as a negative probability.
Yeah. So the third one. Yeah?
Mm-hmm.
Awesome.
It's not. Okay, I was like, okay. I was like, oh, you just said it's not. Okay, do we go over the answers to make sure they're right?
Yeah.
Okay, so 3, true.
Mhm.
4.45, right?
Yeah.
5.55. these right so far?
Yeah,
right?
this is all right so far.
Okay. 10.84, and then 11.24, 12.27, and 13 the third one.
Yep.
Yep.
Okay.
Okay, let's submit it.
93%.
Oh, what did we get wrong?
Oh, it was the 1.167.
How did we get that wrong?
I have no idea.
I don't know. Round that to 3 decimal places. That's what we did.
Huh. Well, that is weird.
Oh gosh. Okay.
Well,
Well,
Okay, so the probability would have been 1 in 6, right?
yeah.
Uh-oh. We didn't read it right. It's 7. 7 bowls containing urine were lined up.
Oh. The six of the samples were from patients who did not have bladder cancer, but there was
Yeah, it was
we were just
7
counting
bowls.
the 6. Oh. Well, at least we know we did it right.
Yeah, so it would have been 0.143.
oh, okay.
Oh, that's
Dude.
so sad.
You can know it now.
Dang.
Next time we're gonna get them all right.
Yep.
Okay, so when do you guys want to meet again?
Wednesday, tomorrow.
Pull up this calendar. Yeah, can you guys do tomorrow at 9?
At 9?
9, yeah.
Yeah, can you do that?
Yeah, that should be fine.
Okay.
Okay.
Okay, let's go ahead and plan on tomorrow at 9.
Okay. Sounds good.
Perfect. Well, thank you.
Thank you, guys. Thanks for the patient.
Yeah, I think this was actually our most smooth phone call so far. So we're moving up in the world.
Yeah, getting better.
Okay, I'll talk to you tomorrow.
Okay, thanks.
Bye.
Bye.
Bye.